So here we're being asked to construct our own polynomial from what we are seeing in the graph. First of all, you want to identify where the zeros are. We have a 0 at x equals -1. We have a 0 here at x equals 1. And we have a 0 at x equals 2. Our polynomial is going to come in the form of x minus c1 to a power times x minus c2 to a power times x minus c3 to a power as well. This is because there are 3 different zeros. So we could have up to 3 different linear factors with various multiplicities. So I'll call it 3 unique linear factors. So what are the zeros? C1, C2, and C3. What are the unique factors? X minus C1, x minus C2, and x minus C3. Now they also say that they want us to use a leading coefficient of 1 or -1. What that means is that the a needs to be -1 or +1. Now when we make our polynomial, we should include the possibility that there could be a leading coefficient of a. Now any polynomial that goes up on the left and right has an even degree. Now why am I saying that? Because if you look at the pattern of polynomials, like if you look at y equals x, he goes up and to the right as well as down and to the left. If you look at x squared, he only opens upward on both sides. And then if you do a cube, x cubed, it's going to cross through and go both up and down. Whereas x to the 4th only opens upward. And so this pattern continues. If you have an even power, you're going to be opening upward or downward if your coefficient's negative. So this is definitely an even degree polynomial based on that. So we're going to have a positive coefficient of a. All right, so now let's plug in our a that we chose. Let's put in also our zeros, which are -1 and 1 and 2. But the problem is we don't know the multiplicities yet. So we have to find those. Now they're saying to make the degree of f as small as possible, which means we want to look at the features, like the behavior of the graph around those zeros, and pick a multiplicity that's the smallest that it could possibly be. So take your x equals 1. That cuts straight through. Whenever we cut straight through, we're talking about a multiplicity of 1. So that means that his power is just going to be a 1. For the x equals 2 factor, we're turning around, which means our multiplicity is going to be even. The smallest even number, of course, being 2. Since they want the smallest degree, let's just call it a multiplicity of 2 for x equals 2. And then for this guy, we're cutting through the x-axis, but we don't cut straight through, which means the multiplicity is at least 3. And so I'll go with the simplest case, that it's 3. And so this is going to be my final polynomial. So let's type in the formula that I created here. And yeah, as we can see, it really does match up to the graph on the page quite well.